Hello Algebra 2 folks, and welcome to Unit 1, Functions and Operations. Today we're going to start Section 1, and we are going to start learning about the real number system. The learning objective for today, and I need you to write this down, is I can classify and identify numbers within the real number system. This is what the overall of the real number system looks like. You do not need to write this down. It's just a visual representation of where all the numbers fall in the real number system. But before we take a look at all of these parts, we're going to go ahead and just focus on rational numbers and irrational numbers. Rational versus irrational. Rational numbers are numbers that make sense. Irrational numbers are numbers that don't really make sense. And yes, you do need to write this down in your notes, please. A rational number is any number that can be written as a fraction, or I might use the word ratio. Fraction and ratio are the same thing. Fractions, 2 over 3, that's a ratio of 2 to 3. Whole numbers, a whole number is 7. And it can be written as a fraction, 7 over 1. Don't forget that you can take a number and write it over 1. Integers include the negative numbers. So negative 18 is an integer. I can say negative 18 over 1. Terminating decimals are decimals that end. They stop. Okay, so 0.49 is the same thing as 49 over 100. Repeating decimals are decimals that repeat, so 0.77777 repeating would be the same as the ratio 7 over 9. Irrational numbers are non-terminating and non-repeating decimals. So they're decimals that don't stop and they have no repeating parts to them. And they can't be written as a fraction. Okay, so the square root of 3 is the same as 1.73025, and it keeps going forever and ever and ever. It never repeats, and it never stops. 1.212112111, it looks like it's repeating, but that's not a repeating. That's just a pattern that's happening. Okay, so I cannot take that decimal and write it as a fraction. Same as the next one, 0.123456789. It appears that it's a pattern, but it's not repeating. So it cannot be written as that ratio. And if it can't be written as that ratio, then it is called an irrational number. Now, if we're going to talk about the real number system and just the rational side, you'll notice that there are multiple things within the rational numbers. Okay, so I'm going to explain this, and again, you don't need to write this down and you don't need to write this page down, but I'm going to explain this by using the Russian nesting dolls. If you've ever seen a Russian nesting doll, the smallest doll goes into the next size, and then the next one goes into the bigger one, and then these three all would go into this one, and then they would all go into the last one. That's a nesting doll. So the item is a member of the smallest box. When an item is a member of the smallest box, it becomes a part of the larger container. Okay? So this means the natural numbers are a part of the whole numbers, because this nesting doll can go into this doll. And then the whole numbers, okay, the natural numbers are a part of the whole numbers, which are a part of the integers, which are a part of the rational numbers. So these nesting dolls, each part is, the smallest is a part of the bigger, okay? But integers, this doll would not fit into the whole number, because this doll is too large to fit into this doll. So it doesn't go backwards, and only goes from the smallest up to the largest. Okay, so that's kind of how you need to think about it when you're looking at these numbers. So I want you to go ahead and write down the inside of the rational numbers. So the rational numbers include the natural numbers. Those are the smallest ones. The natural numbers are the numbers that you would naturally count. That's why it's called a natural number. We also call these the counting numbers. Lots of people call them the counting numbers. They're also called the natural numbers. So if I'm going to start counting and I were to count people in the room, I wouldn't say Johnny is 0. I would say Johnny is number 1 if I'm going to count, and then Joey is number 2, and Tanya is number 3. So I would say 1, 2, 3. Whole numbers are the next one up, and if you notice, the counting numbers are within the whole numbers. So the whole numbers, now they include 0. So if I have 0 books, I can say that's a whole number because I don't have any. Then the next one up, so the third doll would be the integers. The integers include the counting numbers, they include the whole numbers, but now they include a little bit more. So they also include the negative whole numbers. So -1, -2, -3, -4. Okay? And then from there, everything else would be a rational number. Okay? So if it doesn't fit in the natural, then it would go in the whole, or the integers, or the rationals. Okay? So you're going to kind of have to decide where these all go. Now, what I want you to do is take the piece of the sticker that I gave you, and I want you to put that in your notes, and then I want you to spend a few minutes maybe pausing and making sure that you can put these in the appropriate spot. And then I'm going to go ahead and do it for you, or with you, to make sure that you did them right. All right, so take your little sticky real number system out, put it in your notes, and begin putting these in the places they belong. So I'm going to start with the square root of 2. And the square root of 2 would go into the irrational number. When you put it in your calculator, it's not going to terminate and it's not going to repeat. 2.73 is a decimal that looks like it's ended at 3 because there's no ... behind it. So it's not a natural number because it's not 1, 2, 3. It's not a whole number because it's not 0, 1, 2, 3. It's not an integer because it's not the negative whole numbers included. So this would just be a rational number, 2.73. I'm sorry, I forgot the -6. The -6 would go into the integer value because it's negative. The square root of 9, a lot of people might go, oh, the square root of 9, that's an irrational number because it has a square root. But it isn't. When we put that in our calculator, that would be 3. So it's a natural number because it turns into a 3. Okay, now we've got 3/7. 3/7 is a rational number because it's written as a fraction, but it's not a whole number, it's not a natural number, and it's not an integer. -100 would be an integer. 0, okay, remember 0 doesn't fall in the natural or the counting, so it goes under the whole numbers. Pi is 3.14159, blah, 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 and it keeps going forever, so that would be an irrational number. 1 would be a natural number. -1/2, now I know it's negative, so you're thinking, well, maybe it'll fall into the integers, but remember, integers are the whole numbers and 0 and the negative whole numbers. So the -1/2 would be a rational number because it's a fraction. A -3.8 would also be irrational because it terminates. It's a decimal that terminates. 5.42 is a repeating decimal. That line above it means repeating decimal, so it would go under the rational numbers. 8.293017 ... Oh, it doesn't look like it's repeating. It doesn't end, so it's an irrational number. -18 would be an integer. And 75/15. Well, that looks like a fraction. So a lot of people are going to go, oh, well, that's a fraction, so I'm going to put it in the rational numbers. But it can be simplified. So be careful if numbers can be simplified. It's actually going to be a natural number because it simplifies to 5. All right, now that you have these in your notes, we're going to go ahead and identify each number below as a natural, a whole, an integer, a rational, a irrational, and or real. More than one may apply. So I want you to think about the nesting dolls when we're talking about this, or think about, the visualization of the real number system that you have in front of you. -4/5. Well, it's a fraction, so it has to be a rational number, and it's real because everything that we're going to talk about right now is real, but later on in the chapter or later on in the year, we're going to talk about imaginary numbers, and then they're not real anymore. They're called imaginary. So this one's rational and real. Okay? -9. -9, it's not a counting number because you don't say -9 people. It's not a whole number because you can't have -9 pies. So it's actually starting with an integer. But if it's an integer, remember, then what's the next doll up? Well, it can be irrational and it's real. Okay? The square root of 16 is the same thing as 4. So 4, I think that's a counting number because I can say 1, 2, 3, 4 people. I can say it's a whole number because I can say I have 4 books or 4 pies. And then so it's a natural, it's a whole, it's an integer, it's a rational, and it's real. Okay? I'm just going to move that 4 over so that you can see that says natural. Okay, the negative square root of 25 is actually the -5, and -5 would, because there's negatives don't start until we talk about integers, and this is a whole number that's negative, so this would be an integer, a rational number, and real number. The square root of 8 is a number that probably doesn't repeat. I'm just going to put it in my calculator here real quick and see what I get. It's approximately 2.828427. It doesn't look like it repeats. It doesn't look like it terminates. So therefore, it is irrational. But remember, irrational numbers are still real numbers. Okay, so that's all I have for you today. I'll see you tomorrow, and we will begin the next lesson.